Folks. So, going to do the computer thing again. I've got these files right here. We'll talk about what's in them. But first and foremost, the PLL boards for the Cobra 2000. They've been shipped, so I'll have them. Oh, I don't know, probably 3 weeks. But stuff. That one I didn't have it shipped in any speedy fashion. So, anyways, I got these pictures right here. Mike took these. I tried to take some of mine. I couldn't get as good of pictures. I'm just sort of, yeah, I'm photographically challenged. So these are of the SSB 980, 980 SSB, whichever. Um, there's the front panel. There's the Renesas microcontroller, the UPD 78 F0483. Nothing too fancy there. It's just a microcontroller. But however, they've got it fairly well secured. Um, Minimal manipulation, and rightfully so. They don't want somebody to, just dump the code and just be able to change it. That said, um, I have some sneaking suspicion they put some countermeasures in there as well. So I'm not fooling with it. It's just not worth it. I'm going to go around this microcontroller and EEPROM combination because we've got a little EEPROM, but this is for storing user stuff. We've got some pins here, and this is pretty much probably for mass production's bed of nails, flashing it. But we don't have a header or anything in here. Just various test points at various places. This serial UART that's used for flashing it. But there's really not a whole lot here that's interesting. This is the next guy right here. Now this is a like a bus expander or a I/O expansion for a microcontroller. You would think that with this, there's plenty of I/O. Why would they need to expand it? Well, they're using most of it for the LCD. So, and this is pretty much all LCD drive all through here. So they're using virtually all of it for LCD. This the bus expander, and this is pretty much just used to control modes and other things. This is the PLL and VCO. This is the PLL. Yes, this little dinky sock that is right here this is the PLL. This is the VCO. This is the attack point. Not this. Not this. We can talk to this. We can't talk to this. And we can talk to this. Now, this is just a PLL. There's not a whole lot different in how this works than how, say, an 8719 works. This is just serial. The 8719 is parallel. So, the word that we're going to put into the 8719 is parallel. You just high, low on the pins, and then you have your word. This, we have to clock it in. This is an op amp. This is an op amp. Nothing too fancy there. So, and that pretty much concludes the interesting photos, except for the attack point. Now, not in this can. We're not really too interested in this, although, maybe at some point, depending. But right now, we need to talk to this. And there's a data sheet for this, and that's this wonderful gem right here. So, we just need to be able to program this chip. And it's not that hard. They tell you how to do it in this data sheet. So when I said that everything that you need to know to crack this radio is in data sheets, I wasn't kidding. I got a couple of emails. No, there's nothing in the data sheets for anything. Okay, well, we'll just go to those pages. Oh, we have the configuration word layouts. Oh, and the counters. Oh, and the divide ratio. And we even have examples. I said it's in the data sheets. And here it is. Here's the math. So you want to get that radio to go to a specific frequency? Just tell the PLL to do it. It's just that simple. I'm not kidding you. Just tell this guy to do it. Who gives a shit about what the microcontroller wants? You cut these 3 pins right here, and you send it your own initialization, and you program it your own way, okay? And this thing isn't the wiser. It really isn't. This thing doesn't know that this thing's gone. You cut that and that's it. It's just severed. So the attack vector is right here. And it's been staring everybody in the face because everybody just wants to go to where the display is. You know, this thing right here. Oh, well, the display. You know what? The more modern these radios get, okay, this is all fine and good. The more modern these CBs get, the more things stay the same. Because at this point, it's still a VCO. We still drop into the analog domain and we can still attack it. It they can't. There's just like very little. What they're doing to stop this is they're all of the circuitry is just going to end up in a chip, and then we're going to have problems. But we're not quite there yet. I mean, we're not quite there yet. Still got a PLL, still got a VCO. Um, so, anyways, where is that guy? So here's our PLL, pin 1 and 16, or 18 rather. Um, we've got our programming information, and here's our example circuit. Now, if you look at this, and you look at this, you're going to see some similarities because I think that they almost literally copied most of the example out. That's really, all they did. Now, this is our loop right here. This sets the voltage. This is coming back in. This is our phase locked loop right here. Going in 1, out 4, in 1, out 4. So, um, or 3 rather. My bad. Not 4, 3. So this is our loop, and there's not really a whole lot going on here. Our muxed lock detection, because it is muxed. Clock data enable. Here's our oscillator. We're not using this. So pin 1, pin 2, pin 3. See, these are used. 4 and 5. 4 I don't believe is used. Or 5 rather. I don't think so. I don't remember seeing a VIA under there. I don't think they're looking at the lock detection. 4 is obviously ground, and it is. And I do remember one of these. It's got to be the ground that had a VIA under there to, to ground it out. I mean, it would have to be, obviously. So when we have 6, 7, and 8, that's our data bus. 9 and 10 are connected. They would have to be, as you can see, because there's our second, we need this, and 11 we also need. So 10 and 11 are for the oscillator. We got a crystal here, and you can see we've got our load caps and so on and so forth all here for this wonderful gem. And then we have 12 that doesn't have a connection. Okay, 13 will. Okay, 14, 15, and 16. VDD, this has a connection. This one does not, and this one does not. 14 and 16 are unused. So this second one's just not used. And there's 2 configuration words, obviously one for each. So it's not that difficult. So long story short, now that I've shown, I'm sure that everybody can breathe easy. How is it done? Because I mean, this isn't. It's still going to be difficult. I mean, you're still going to have to understand what's going on, and you're still going to have to figure out how to do it. I told you where to look now. Now you tell me how you're going to do it. I'd like to hear it because the way I've done it, at least for now, just to get this radio to go to other frequencies, and I have, um, it's just simply with a bus pirate. So anyway, fellas, that's basically it. There's the explanation. There's the proof that it can be done. Here's the data, all here. Throw a bus pirate on it. Just tell it what you want to do. Just send these configuration words to it. Do the math, um, and have at it. And it's not hard math. So anyway, take care, guys. You have a good evening and a good day and all that wonderful stuff. And when I get the other boards, um, in fact, I might have my replacement chip. I actually tanked one of these chips. I was um, I had basically soldered some clipped leads. I've got tons of them. When you clip resistors, capacitors, or whatever. And you save the little leads because I saved little leads, and you solder those on there so that you can clip test points. Little mini grabbers to these pins so that I could interface with the bus. I mean, I pretty much just took because I didn't want to pull this chip out. I chip quick this thing, pulled it out, looked at the tracks on it, took a picture of it, which I don't have the picture here somewhere around. It's on the other computer probably. Um, took a picture so I could see what was under it. Soldered my chip back down, soldered pins to this, and I was working on um, sending data to it. And I was, just at that point, I was just goofing around, playing around with the formula, goofing off, getting the radio to like 10 meters because, yeah, I was able to put it in 10 meters very easily. Um, uh, you know, that's another thing I have to evaluate is just how sensitive the thing is, you know, when it's out of its realm. So um, I was, anyways, mucking around with this, and I uh, got a mini grabber crossed up with something else, fed slightly too high of a voltage into this thing, and well, let out the blue smoke. So, the radio's dead stick, obviously, with no PLL. So you got to be really careful about these SOT packages, because um, I, we've got these vias here that I could solder to, um, but what I did is I cut the tracks here, and the reason I cut them here is because they're easier to repair here than they are going to be, somewhere else down in here. So I just exactoed it like right there to cut these tracks because I gotta separate this from the microcontroller because this thing's communicating with the microcontroller and I don't want it to talk to the microcontroller. I don't want the microcontroller sending it data. So I obviously had to physically sever them to do that because this bus is shared with uh, the other bus expander. So I had to sever that and had soldered three little wires. Like I said, the little component leads, and then accidents happen. Let the blue smoke out. These things you can get them on eBay from China. Um, Nobody's really working with them because they're pretty much working with the analog devices or the Silicon Labs, like I am, and these are kind of obscure. Um, I'm not entirely sure why Uniden is even really using this, to be honest, other than it's probably cheap and they probably got a whole bunch of them because I mean this is for all intents and purposes a Chinese bit from um, almost 10 years ago. So um, it's old. So that said, that's basically it, guys. Not a whole lot else to report. So take care of yourselves. Catch you later.